welcome to the last Science Chat meeting before the summer break. We were very happy to have Javier Garcia Bernardo today here. He's an assistant professor at Utrecht University and is currently interested in social data science, corporate power inequality, but also machine learning. And he will give us a talk today about using predictions for understanding.
For organizing this. Thanks all of you for coming. How many of you here are from social science and economics? Couple. And how many of you are from hard science and physics and math? And environmental science? Anything else? Nope. Okay. Good. That's a good mix. I'm gonna be telling you a little bit about my new work started this year about how can we use prediction for understanding, which is what we care about in social science, also in complex systems. A little bit about me. I think already your explanation was quite good, but I care about inequality, polarization, like why are we living in such a backup world? Methodologically, I care about networks and prediction and how can we combine prediction and machine learning with like really understanding society and understanding these factors. And I have quite a eclectic background coming from biology to computer science, complex systems, economics, political science, and then now I'm in sociology / methods. But I always feel I'm really close to complex systems. Like that's how I would define myself. But you are not here to hear about me, but about my research. But a couple of things before that, I was just reminded that there's an Odyssey conference. If you're doing things related to social science, economics in any type of way, there's a deadline this Friday. It's a really nice conference. It's free. It's in Utrecht. And you meet really nice people doing really amazing work. And we also have a network science summer school. It's in 2 weeks here in Utrecht. If you're interested about networks or if you know anybody who wants to get introduced to networks, this is a great opportunity for it. All right, let's start. Upward mobility is stalled in the Netherlands. It takes now for children from low-income families 4 generations to reach the average income in the Netherlands. If you look at educational levels, so here is your parental educational level in the x-axis, and here are the probabilities of completing or attending college compared with the probability of completing only private school by age 24. Right? So if your parents only have private school, you are as likely as completing university as just staying as your parents in primary school. If your parents have a postgraduate, then you're 26 times more likely to go to complete university by age 24 and 200 times more likely to actually attend university.
Sorry, just one question. Is it both parents or just one parents?
So for primary, they will be the parent with the highest education. Yeah. So please stop me. Any type of question, please stop me. And you may say, okay, there may be some genetics here, but this also happens if you control by the teacher recommendation or even the scores at the school. If a person whose parents had a postgraduate degree receive a median advice, so median advice here means this person should not go to university, and the probability of actually completing university is around 40%. The same as like a person, very similar to a person from a family with only primary school educated parents, where the teacher said this person really has the capability to go to university. So, inequality in education, inequality is extremely important in the Netherlands, and we are even quite unequal country compared to others. So I hope I convinced you inequality is important. I think you were all quite convinced. But something that we know about educational attainment, educational outcomes are that social context matter a lot. So social context, I mean families, classmates, your neighbors, your colleagues, all these social contexts matter a lot, but they also interact in many different ways. We actually do not know many of these interactions, both like theoretically or empirically. We have not measured them, we have not studied them. So my idea was, for example, like how important is to go to a school where the parents of your peers have a diverse background. We just don't know. And is that more important in urban areas or in rural areas? We also don't know. So my idea was, let's try to use prediction gaps to uncover what interactions are important. And I'm going to explain to you in a bit what do I mean with prediction gaps and why this may be important, more broad than just this context. Right. So prediction gaps, I mean the difference in predictability between a simple model driven by theory and a more data-driven model, a machine learning model. If there's for example, create statistical model driven by theory and is able to predict an accuracy of 20% who is going to university and who is not going to university, and then using the same data, you create a data-driven model that is able to predict with 50% ability, then there's a prediction gap between both of them. And this prediction gap really intrigues me because it means that there is something in the data that we have not considered it important that is very important. So if we know there's a prediction gap, then we can try to understand what drives this prediction gap and then bring it to the normal scientific cycle. We have some observations from the real world. Maybe the diversity of your parents is really important. We look at how it fits with our theories. If it doesn't fit, we need to theorize more. We need to test hypotheses. And since there is not a lot of people from social science here, I want to tell you a little bit about what social scientists care about. The main goal is to understand mechanisms. But we really want to know why things are happening. And our approach is theory first and then test hypothesis. We think very hard, or like normal sociologists think really hard about what may be happening. They come with some hypotheses, they have some expectations, and they test them. Usually they test them with simple models like a linear regression or a logistic regression and with some p-values. This is quite different from what data scientists do. There, the main goal is not really understanding, but uncovering patterns. And the approach of data scientists is first the data. You start with the data and then you try to uncover some patterns, or you try to predict something very, very well. And the models, because you are trying to predict something very well, usually are very complex based on machine learning. And somewhere in the middle is like complex systems, or like us. There, the main goal, how I see it, is that we try to bridge the gap between the micro world and the macro world. The approach, we usually start with models first, not with data or with theories, with methods first. And the models are usually very diverse, but focus more on mathematical or generative models. So these are like the three approaches, and I kind of want to combine them a little bit more. So to make it a little bit more explicit, how would a sociologist do research? And this is one theory, the segmented assimilation theory by Cortes and so, where they hypothesized, or the theory was that the success of children of immigrants depends not only on their background, but also on their social context, on the social networks. So particularly the socioeconomic status of the co-ethnic relationships. And so the idea is that if you are poor and everybody else around you is poor, you don't have really like models to look at, or you don't have even support. So you are likely to stay poor. But if you're a migrant child and then you have some people of your same origin that are having good jobs and successful, then they may offer support, they may offer role models. So how would a sociologist test this? Then this is the theory, then they would have some expectation that if there is a lot of co-ethnic peers let's say, whose parents completed university, then the educational attainment of a child will be higher. So they will run a regression, they will look at the coefficient. If the coefficient is significant, they would say, okay, I proved my theory. It's a bit more complicated than that, but it's mostly that. But this has quite a few limitations, and the limitations are that the interactions between social context and individual characteristics needs to be explicitly modeled. We need to create this indicator of like percentage of co-ethnic peers whose parents completed university. If we do not include this, then yeah, we cannot analyze it. And it also assumes that this is actually what matters, that is the percentage and not the absolute number, for example. And also assumes linear additive effects. There is no nonlinearity, there is no interactions unless we include them explicitly. And to me, these are quite big limitations that we need to understand if they're important or they are not important. And that's kind of what I want to talk today about. I want to focus on what is the impact of social context and college completion, or what the relationship between those two things. And I have 3 goals to talk. One of them is to estimate this prediction gap, this difference between theory-driven models and data-driven models. And as I said before, this is important because it can help us reveal things that we didn't know before. The second one is to evaluate which social contexts are important. And the third one is to assess which groups are predictive. And this is important because of a very similar reason. If we can predict very well which boys are going to university, but not, let's say, which girls are going to university in Utrecht, well, there is something different between boys and girls that we don't understand, but it's not in our models that we need to understand. So just by looking at these differences in predictability, either between models or between subpopulations, we can get insights about what is actually going on. I'm going to study it using 180,000 students transitioning from primary school to secondary school in 2011. So my variables are from 2010 when they are still in primary school, and the outcome is in 2023 when they are around 24. And yeah, my collaborators are Eva, Weberson, Eric Jan, and Samuel. And for those who do not know the educational system in the Netherlands, is a bit complicated. Well, children are tracked at age 12. After primary school, you know if a child is going to go to university or not. And so they go to primary school, and then they can be tracked into the FBO, HABO, or vocational education. If you go to vocational education, sometimes you can go to HABO. If you have to HABO, sometimes you can go to FBO. You see a lot of errors that indicate transitions, but in reality, those transitions don't happen very frequently. So what is happening is that if you go to vocational education, then you end up with a vocational education diploma. If you go to HBO, you end up with an applied science degree, like this is still university. And if you go to FBO, you end up with a master's. That's kind of what happens for most people. Here I'm talking about completing college. This is my outcome of interest, both going to applied university or research university. So this is the educational system in the Netherlands. And it's very unequal. Like, if you look at the wealthiest parents, 80% of the kids will end up here. If you look at the poorest parents, 80% of the kids will end up here. So this is also why I'm studying primary school, because when they are already in secondary school, it's already very clear who's going to university and who's not going to university. Okay. And I'm using data from Statistics Netherlands, and this data is great because it provides information about the social context for the entire population, which usually you cannot do with any other type of data. So I have my 180,000 children, and they are connected by 6.6 million connections in school. A connection means they are going to school together. And those kids have parents. That adds another 360,000 parents. These parents have grandparents, another 700,000 grandparents. And all these people have neighbors. That's another like 5 million neighbors, which is already like a third of the population of the Netherlands. So starting from my 880,000 children, just going a few levels down, already have 1/3 of the people in the Netherlands in the sample. Okay, that's the data. We not only know the context of these people, but we know a lot of other things. We know who went to university, who didn't. We know the income. We know who got vaccinated. We know everything. Basically, everything the government knows about you is in this data. It's very secure. You need to work in a very secure environment. But if there is information that is useful for research, for your research, you can get access to under very strict conditions. All right, so the first goal, to estimate the prediction gap. So again, why do I care about this? There are two reasons of why we may have a prediction gap. The first reason why we may have a prediction gap is because of model specification. Let's imagine we compare a simple model like logistic regression and a more machine learning model like gradient boosting. So they are using exactly the same variables. I think I don't need to explain you what those models are. But if there is a difference between these two models, that means that we are not including important nonlinearities or interactions in the logistic regression. Because if we had included them, if we had them in the logistic regression, the logistic regression would predict very similarly to the gradient boosting.
Are you assuming here that the gradient boosting or any other machine learning algorithm is, let's say, perfect and able to uncover all the patterns that could be uncovered in the data?
No, I mean, that's going to depend on many things, including the sample size. So, yeah, you shouldn't see this gap as like the maximum possible gap, but just as a already
Some indication.
Yeah, like if there is a gap there, that means you are missing something in the logistic regression that was very important. And given that the logistic regression usually is driven by theory, that means that you are probably missing something conceptually. Yeah. Okay, so this would be about model specification, if there is a gap between those type of models. But what I also care about is this second gap, comparing a gradient boosting with a graph neural network. A graph neural network does not just model individual level variables, but it models the entire network directly. So you have a network with different types of nodes. The nodes have different type of properties, and this is combined in some way that I'm going to explain in a second in order to create these predictions. So the difference is that while for gradient boosting or logistic regression, you need to operationalize your variable. You need to say, what I care about is the percentage of co-ethnic peers in the network. For graph neural network, you do not need to do that. So if there is a difference between these two models, that means that we are not correctly operationalizing social context. So maybe this segmented assimilation theory is extremely important, but if we didn't include the percentage of co-ethnic peers whose parents are highly educated in our model, then we wouldn't be able to find this out with any of the other two models.
So all three are assuming the same variables?
They're assuming the same data. The first two have node level features, while this one has the node level features and also the connections.
And is it in the third one, is it just the edges, like one step, or is it all possible steps away from?
Is the entire thing. I'm going to explain how the network works in a second. But the network I'm using is this network. So we have children, we have the parents, grandparents, and neighbors. Different type of relationships, different types of nodes. And how many of you know how graph neural networks work? Zero, great. Perfect. Then this slide is very useful. So they work by combining information, by doing message passing and feature mixing. So what do I mean with this? Let's imagine we have a very simple network here. This is a really nice tutorial if you want to understand more about DNS. And we have some node features. Let's imagine this is the age of the people, even when some of them are negative. So how does this work? From the neighbors of A passes messages to A, and then they get aggregated in some way. So the neighbors of A, so B, C, and D, pass the message, and it's aggregated in some way. In this case, it's aggregated using the mean. And then we are also adding the value of A, and this B and W are some ways that we're going to learn with backpropagation. And then we just aggregate these, and it gives a 3.67, and then we use a nonlinear function, a ReLU. A ReLU means if the number is negative, you have 0. If the number is positive, you have just the number. So because this number is positive, we have 3.67. So what's happening is just it's integrating the messages from the neighbors in some type of. And then you do this again. So you do this for every node. For A, it was 3.67. So this is the new embedding of the node. And then you keep doing this. You usually do it 2 or 3 times.
This network is kind of directed or non-directed?
It can be both. In my case, is directive. But
you also assign as the different sign to them? So
what do you mean?
Positive and negative for this value, or
you could, but I mean, this in the first step, these are the node features. So in my case, this could be things like the income of the node, the people, or the educational level, or the migration background, or the age. And then they get combined into a node embedding, and then they get combined again into a different node embedding. You have different layers. Yeah.
So why are now the numbers here for D, B, and C changed? Are they the same numbers as in the first one, or?
What do you mean? Which numbers?
Like from B goes from 4 to 6, and D from 0 to 4, because you do the same thing also for those nodes, and then they change.
Yeah, exactly. Okay. Yeah. And we could also use this is just a matrix multiplication where the adjacency matrix is multiplied by embedding by some way that you are learning. And then this is passed to a nonlinear function like this ReLU. But the main idea of these GNNs is that they combine information from the neighbors and the information from the node itself in order to predict something. In my case, who's going to complete university and who's not going to complete university. More or less clear how the GNNs work? All right. So we already set up 2 things that could create the prediction gap: model specification, like the interaction non-linearity, or that we didn't have the correct model variable operationalization. We could also try to throw all the data to a GNN and see how much it predict. That would be another third gap, which would mean there are information in the data that are proxies of mechanisms that are not included in the other models. You could do that. I did not do that. I'm not going to talk about that in the rest of the talk, but in principle, you could still do that. You could go up a level further. But for the rest of the talk, I'm only going to use 3 models that have exactly the same information, so it's fair to compare between them. Okay, so I'm starting with my network. It has like children connected in the schools, parent relationships, it also has neighbor relationships. And I'm using 3 different models: a simple HT regression, a gradient boosting, and a graphical network. And as I explained before, the difference between these 2 is that we are missing key interactions and nonlinearities. The difference between these 2 is that we are missing social complexity within the social context. And all the models use the same data, and all the models use also the same loss function. And all the models are evaluated in the same way, using the Matthews correlation coefficient. This coefficient is the equivalent of Pearson coefficient, the Pearson correlation, but when you have binary outcomes. And the advantage is that even if you have unbalanced population, so like a group where like 90% of the group goes to college, you still can compare it with a group where, let's say, 10% of the group goes to college using this metric. With other metrics like F1 or AUC or anything like that, you cannot do that. Okay, and the data that I put in the models are like a lot of things related to demographics, like birth, year, migration background, disability, things about the nuclear family, like parental education, parental income, household income, extended family, like if the grandparents live together, what is the wealth of these people, things about the school, what is the class size, is it in an urban area or rural area, what is the mean income of the parents, the classmates. Also the same for the neighbors, what is the average standard deviation of education and income neighbors. Yeah.
What's the WPO?
Yeah. That the educational weight is given by the government to families to allocate funding for a school. So the idea is that if the parents have very low education, those children usually require more resources, so school get more money. So this WPO is something that is given to the students that determines that is based on the parental education. And if both of the parents only have primary school, then it's 1.2. If one of them have primary school and the other one is a little bit higher than that, 0.3, and otherwise there is no extra fund. So it really means your parents have very, very low education.
Yeah. Just wondering if you include such kind of a factor, are you not gonna have double information because you already have the education level for the parents, so it's already included in there, right?
Yeah. This is something I thought about, and in social science, they usually don't want to include the same information several times because then it's difficult. Things become complicated to compare. So the reason why I did this is because I'm caring only about prediction for this analysis. So I'm not going to look at the coefficients of these things at all. So if the information is repeated, then that's okay. There is extra information for the parental education. I'm only looking if they went to college or not. So this WPO weight is measuring something different. It's basically measuring did these parents went to secondary school or not. So it's giving complementary information. But in general, I try to throw as many of these variables that usually will go into a social science-based model. Because I'm not going to look at the coefficients. I don't really care if there is like multicollinearity or things like that. Okay, so that's kind of the data. Let's see what we find. This is the predictability. These are the three models: logistic regression, gradient boosting, and GRI. The correlation between the predicted outcomes and the real outcomes for a logistic regression is already quite high, like 30-something%. For social science, that's really high. But using these more complicated models add very, very little fit, which was good for science, but bad for my research. And also, all the models were agreeing on what was important or not. So comparing, for example, I think this is comparing gradient boosting and linear regression. Both were agreeing in 35,000 of the observations. Both were disagreeing in like 3,000 observations, 2,500. Of the ones that they were agreeing, they were both correct in 25,000. They were both wrong in 10,000. And these numbers are around 37,000 because this is my term there, which was 20% of my 180,000 students.
I assume with the latter two models, you use some cross-validation and hyperparameter tuning, blah, blah, blah. Do you do that for the linear model, or do you just fit it once like a normal linear regression?
You fit it once, but also doing this like training and testing.
Oh, okay.
So I'm training 80% of the data, and then I evaluate it on the other 20%.
And this comparison is the evaluation.
On the out of sample prediction ability.
Yeah, because I was gonna say it wouldn't be a fair comparison.
Yeah. Well, exactly. So this is telling us, well, the models are not only like very similar, but they are also focusing on the same type of information. So this is disappointing, partially, but I will explain why not. There's two reasons. One of them is these are small differences, but they can still be substantial for small groups. So we went ahead and looked at are there subpopulations where the graph neural network is actually better at predicting than the other ones? And we found one subpopulation where this was the case very strongly, which is children growing up without a father. This does not happen with children growing up without a mother. So if the father is known by the registry, the three models predict basically the same. If the father is not known, then the linear regression predicts like the correlation is 17%, while the GNN is 25%. So we went a level deeper to try to understand why this was the case. And we look at the prediction gap between the GNN and the linear regression when the father was absent or known as a function of the child's gender. And we saw that if it's a girl growing up without a father, then there's a huge increase in prediction ability when you use the GNN. If it's a boy, not so much. If the mother had college education, the GNN does not do much better than the logistic regression. If the mother did not have college education or had a known education, then it matters a lot. And this is the kind of insights that we like to get in the social, but I'm arguing that we can get with this prediction gap. So we can then try to compare this with theory, and we know from theory and from some studies that boys suffer more educational and behavioral consequences when they grow without fathers, while girls suffer more emotional consequences when they grow up without fathers. And what this is telling us is that girls may compensate more effectively for parental absence. So if a girl loses a father, but everything else around her is okay, like the mother has good education and a good income and lives in a good neighborhood, goes to a good school, then we can still predict that she's going to go to university. If it's a boy, however, then things become a lot more unpredictable. So this is the kind of insights, sociological insights that we can get when we look at prediction. Okay. But, okay. This is nice, it was for a small population, but why is actually the prediction gap so small? And the potential explanation that we had is that parental characteristic is basically the only thing that matters, and everything else matters very, very, very little. And both the mother and the father are included separately in the linear regression and also in the gradient boosting. Like we have the mother education, mother income, father education, father income, mother age, father age. And so what did we do to try to test this explanation? Was to add information layer by layer. We started with a model with just demographics, add information about the nuclear family, then the household, then extended family, then schools, then the neighbors. So this allows us to evaluate which social contexts are more important. And what do we find? If we add demographics, you can already predict quite a bit from the migration background and the age of the student. If you add information about the nuclear family, the parents, then you can predict very, very well. And then if you keep adding more information about other social context, it adds a little bit of information, but not that much. So basically, once you know who the parents are, then you already know most of what is to know. But, okay, if you look at the literature, there's a large body of literature showing that grandparents matter, that schools matter, that neighborhoods matter. So what's happening? Like, why are our predictions not improving once we are parents, while the literature says everything matters a lot? And there are a few potential reasons for this. Maybe we are right and they are wrong. Maybe grandparents and schools and neighborhoods are not important in primary school. It may be that there is information that we don't have at CVS, for example, school teacher quality, or if you live in a neighborhood where people control each other so your children don't get into trouble.
Yeah, just kind of, because all the literature says all this matters is probably they have a massive research, not only in Netherlands, right? So, but what you based here is only the data from Netherlands. Probably if you extend to the other country, that's could be different because culture is different. I would say, according to my personal experience, that indeed is here as grandparents doesn't matter, and school, yeah, a little bit neighbors, very little. But if you put it in China, that's totally be different. The grandparents really matters.
Yeah,
and neighbors, some places, especially not in the city, actually also matters a lot.
Yeah, so I mean that's a good point. There's a huge geographical differences. I mean this paper is about the Netherlands. This is not, but there's another paper about the Netherlands saying that neighborhood matters. And I think for the grandparents, I don't know any paper in the Netherlands, but probably there are some. But it's not just geographical differences. Schools matters and neighborhood matters in the Netherlands as well. And the reason why they don't contribute to predictionability is because the social context mediate the effect of family characteristics. So what do I mean with this? It means that you have educational attainment, are you going to complete college or not? Some families matters a lot, but also schools matter a lot, but family determines when you go to school. So once you know who the family is, you know what the school is, and it doesn't increase predictability because you already know what the school they're going to go to. So let's test this a little bit. Let's imagine we put household income here and school income here. This is a proxy of, let's say, school privilege. And what do we see? We see a huge concentration of inequality. If you are in a very rich family, you go to a very rich school. If you are in a very poor family, you will go to a very poor school. And if you're in a rich family, you will never go to a very poor school. If you're in a poor family, you will never go to a very rich school. But yes, once we know the family, we already know the school they're going to go to. There's a little bit of variation, but we can go a little bit further and say, what is the probability of people completing college based on the place where they are in this square? So here is household income again, and here is school income. And we can see there is a little bit of gradient in this way. So if you increase the school income rank, then you are more likely to complete university. But there's especially a huge gradient here. If you increase your household income, then you are a lot more likely to go to university. And what is important here is that this is kind of the range where people move. So, okay, if you take a person from, like, let's say, the 25th percentile, where they go to university, maybe like complete university, maybe 25% of the time, and you bring them to the best school, maybe they would go to university 50% of the times, but that never happens, or almost never happens. So once you know who the family is, you know what the school is, and then it doesn't increase the predictability. So the school's neighborhood may still be important. It's just the impact, apart from as a mediator of family characteristics, is not very important. This may be different in China, where it would definitely be different in Spain, for example. So an open question is, how can we separate these causal effects of different social networks or social contexts? Which is something that will be really, really good, but it's very cheap. Okay, so we look already at two things. We look at this prediction gap, the difference between the prediction ability of a simple model and more complex models, seeing that this difference was very big for girls growing up without fathers. We also look at which social context matters. We've seen how influential parental characteristics are. And then the third thing that I wanted to talk today is about which groups are predictive. And this is important because it points to different mechanisms. If girls are predictive, but boys are not predictive, then means that something is different for girls and boys. Okay, so we use only the graph neural network, just one model, and we look at the predictability for different subpopulations. And what do we find is that disadvantaged children are harder to predict. So this is the educational way that I explained before. This means both of your parents did not go anything further than primary school, or only 1 or 2 years. This is one of your parents went a little bit further, and this is everybody else. So if your parents did not pass primary school, it's very difficult to predict who of those kids are going to go to university. If you are in a school that is very poor, it's very difficult to predict who's going to go to university. If you live in a neighborhood that is very poor, it's very difficult to predict who is going to university. And looking at migration background, if you are from a Turkish or Moroccan background, it's very difficult to predict who's going to university. Except if your parents are rich. So, or richer, not actually. So we look at the household income here in the x-axis and the predictive ability. And if you are that, it doesn't matter too much what the household income is. The predictability of GNNs is more or less the same. But when you are from a Morocco or Turkish background, then it's very, very difficult to predict. This is a predictability of 0. Until you are in the 70th or 80th percentile, when suddenly you could predict better. So looking back at this theory that I mentioned before about segmented assimilation, where you are more likely to succeed if you have role models around you, this could be something that is related to that. That if your parents are poor, you probably live in a school, in a neighborhood that is also very poor, and go to school that is really poor. You have no role models, no support. You end up being impossible to predict, basically. And while if your parents are richer, you probably live in a better neighborhood or good school, and become more predictable. Yeah.
For your last picture, if you're not from a Dutch parents, then you're saying it's impossible to predict whether you as a kid go to the university and succeed or not. Could that be that there are a lot of different variations in those groups, and for the higher incomes, the outcome is often just going to college, and for the other, it's not. So then your model is not really bad, right? It's just big variation.
Yeah, so two things there. One thing I'm not saying is impossible to predict. I mean, impossible to predict with this specific model. It would also have to do with like sample size and say that. But the more important point is the measure that we are using, which is this MSS, where this type of class imbalance are corrected for. So what this is saying is that if this is the household income of your parents and you are like from a Turkish or Morocco background, it's much easier to predict who is not going to go to university than from these people who is going to go to university. Because it is true, these people will most likely not go to university, or these people will most likely go to university. But the trick is, can we actually predict of these ones who is not going to go to university and of these ones who is going to go to university? And these metrics allow us to do that more fairly. So yeah, it's not just a result of class imbalance. Yeah. All right. So our great expectation that we had is that more complex models were going to give us more predictability, and we were going to learn so many things about how society works. The reality is that that was not the case. Why? There's several reasons. One of them is that long-term predictions are very hard. I mean, we're taking kids who are in primary school and trying to say who is going to go to university, who is going to finish university. But still, we got some nice findings. Parental characteristics are extremely important. I mean, we already knew that, but this is very, very important. Also, that the relationships are relatively simple. This logistic regression was already good enough. And this is good for science because we have a lot of ways to work with these logistic regressions that we don't work with the machine learning models. We did find some surprising or promising results. For example, this interaction between father absence and gender. And yeah, there is little impact of social context, not as a mediator of parental characteristics. Looking at our second goal about which social context was more important, our big expectations were that adding different contexts was going to increase predictability a lot. Our reality is that nothing matters after you include nuclear family. Why is this? Is because parental characteristics are so dominant that once you know who the parents are, you know basically everything else. And about our third goal, about prediction gap between subpopulations, our expectation was that disadvantaged students were going to be less predictable than privileged students, and that was actually the case. So, hooray. And this is especially the case for non-Western migrants from poorer but not wealthier families. So this points to different mechanisms and directions for future research, and there's already some research on these topics. It's not that we are discovering something completely new. Already some conclusion. In this type of supervised learning where we know some outcome, these GNNs are allowed to test us whether networks interact in some type of complex way at different scales. And the contribution to sociology is that these prediction gaps can be used as meaningful signals. So when our predictions fail, there is something that we don't know that we need to know. And I think for complex systems, there is something to say about predictability. Very often we focus on models that can replicate qualitatively some type of observed macro pattern. But I would argue that we could also compare those models with data-driven models. And if our beautiful physics-inspired models are much worse at predicting than a data-driven model, there's still a lot that we don't know, that we didn't include, that was actually quite important. So maybe something like benchmarks would help with that, where you are trying to predict what's going to happen in the future using different types of models, some based in physics, some based on machine learning, some based on theory. Not going to repeat the findings again because I already said them 4 or 5 times. But if you, what we want to do next is try to use this approach in contexts where networks are expected to have a bigger impact. For example, secondary school, where primary school peers are not so important, secondary school peers are extremely important, or job opportunities, or things like that. If you're interested in the data, this data is available for research, and we have a lot of different projects using this data. For example, we are looking at, we look a little bit about epidemic spreads in this type of networks. We are looking at life outcomes, or upward mobility, like what I explained right now, but also fertility and mortality. We're trying to understand if vaccination decisions spread in these networks or not. And we also have a lot of survey data that can be linked to this registry data. So, for example, the list panel is something that Odyssey also supports, and it's a longitudinal panel, so over time of around 5,000 households, and you have hundreds of questions about everything you may want to know about those people. And you can link these people to the registry data and then try to understand how networks or something else matters. If you're interested, just send a message. If you are in something related to Odyssey, like the Copernicus Institute, then you can you can submit an application and may get access to the data for free. But that's all I wanted to say. Thank you for listening.
Yeah, thank you very much for the very nice presentation. Now we have around 10 minutes time for questions.
Yeah, a really question for the remark. You suggested that parents are very important and peers perhaps not in this data set that you looked at. But I guess it also depends on the order in which you added to the models. What you showed was first the parents and then the peers. You reverse the order, it may be different.
Yeah, for sure. Yeah, so in that sense, this is something that, I mean, we know from society, but who your parents are influence the school choice, not the school choice influence who the parents are. So this is, that's why I build them in that type of way. But yeah, of course, like if parents affect the school choice, then those two things are correlated. So if you add first the school networks, then that's going to predict also almost as good as if you have parents first. Yeah.
Yeah, because it relates to the multi-collinearity thing mentioned earlier. I think there are ways to give weights to the importance of variables discounting the order, so Shapley values or Sobel indices or whatever. I would be curious if you can create, let's say, a ranking of the importance of the variables for the machine learning predictive case and for the model driven theory driven, and see if there's any difference there in order.
Yeah.
Especially if you add a network, then again, the importance can change.
Yeah, no, I understand what you're trying to get at, which is, yeah, we want to know what matters the most, like especially for like let's say neighbors and school, and which one you include first. Not sure if Shapley values would be the best, because what you really care here is about causality, which Shapley values will not give you. And there are methods for causal analysis of these things. Things, for example, like an instrumental variable approach, where you look at the parents of your classmates or something, and probably the parents of your classmate, they only affect you through the person or something. I mean, that's a bad example actually, but something like that, or the colleagues of the parents of your schoolmates. You probably don't know them, so if there is an influence, it has to go through stuff. So there is ways to analyze it in a more causal way, and I would love to do that, but it's also, yeah, not a straightforward, yeah. But it's very important, so I think, yeah, it's what we need to do.
And can you not also focus on the cases where maybe the school and the parents would like logically give different outcomes, and then see in these cases for which parents bad school, so to say, very good school, but low income parents.
Yeah, I think
so what is the more predictive?
Yeah, so looking at these people over here.
Yeah, exactly.
Yeah, I think there's a lot to do there. I think what you are trying to hint is about matching, trying to match on many characteristics except for one, to try to understand what is the effect of that characteristic. So if it's not just only like household income, but many other things, and if you're comparing a kid that goes to a relatively bad school to one that goes to a better school, then you can get that effect. So yeah, I mean, these are also ways to analyze this in a causal way that I want to explore, but do that yet.
Yeah, thank you very much, first of all, for your talk. Very interesting. So my question, I'm reminded by something that a friend of mine once said. So she was studying to be a clinical psychologist, while I was learning how to model things mathematically. And then at some point she told me, like, when you are a clinical psychologist, you don't have to forget about all the statistical things that you learn, because the person in front of you is probably not like the average person in every way, most likely not. So you have to just sit down and listen to them, and only then you can help them. So when I'm thinking of that and I listen to your story to predict an individual trajectory, do you think that these models also need some like more qualitative component if you want to predict for an individual?
Yeah, absolutely. Yeah. No, this is actually like something that I really advocate to. Like these prediction gaps will get us only so far. But yeah, like this kind of difference in predictability between the Dutch people and the Turkish people. If we want to understand why this is the case, well, this is not going to help you with that, because you put the data and there is a difference in predictability. What you need to do is either do something like more traditional, like a survey, or go in there and ask these people. And there's smaller, the more that you consume, and you consume quite a lot with this type of big data of the whole population, then the most likely is that you can actually ask these people. There was a really nice paper from last year or a couple of years ago where they actually did something like this. They were trying to predict the grades of children using some type of early life characteristics. And then they went to the houses of these people and had interviews with them. They realized there's a lot of different variability of things that may go wrong, that why people are difficult to predict. So yeah, like when you look at this, you need to do more research, and I think qualitative research has a big impact here. But it could also be that these people have different type of complexity, like maybe, which is also sociologically relevant, but these people have more noise in their careers, so they're more difficult to predict. And no matter what, no matter if you know everything about these people, it may always be this case. But yeah, like qualitative research, I think, is very interesting to answer these questions.
Thanks.
Why do you take the maximum of the parents' education level, not the mean or the minimum?
I take both, actually. I don't take the max.
Oh,
I take both. This is something that is created by the government, where they do consider the maximum. So, but for all my models, I put them both separately because I think both of them will be actually important. Okay.
Anyone have a question? You said you would think that in Spain the outcome is different. Why?
We don't track people at age 11. I mean, at age 11, to me, it's crazy early. No. I mean, at least where I grew up, you go to the school that is closest to you, you don't do any of this like 4-dimensional game of where your kids would go to have the highest probability of succeed, like in the Netherlands. So I think there's quite a bit variability, but I think the most important one is this like early life tracking, which increases inequalities in the Netherlands. And there's a lot of research that shows that if you track children at a younger age, then that creates inequalities.
Yeah. It just I came up with something. For the income in your school, maybe you could include the distance to school, because here in the Netherlands, of course, parents are really choosing for school, so they want to go, I don't know, 5-10 kilometers to drive their children. So you could look at what are some choices of parents are really because of the distance. So it's just the closest, because I put just my children to the closest school, even though it's maybe the best school. But also then you can not really exclude, but you can see whether parents are really chosen or.
No, that's a good suggestion to like try to understand what is the causal impact of the school.
Yeah, because now your relation between the school income and the parents' income is just, I don't know, almost 1, because it's just It's
like 0.5 or something. It's very high. No, exactly. So I mean, I have to say
So I think there are reasons why people are just doing things for school.
Yeah.
And you can maybe think about that before, well,
Yeah.
before you go interview 180.
Oh yeah. I don't know how to make that list. I'm not gonna do that.
No, but I think there are things to.
Then yeah, and one of the things that you can do, I mean, once you know that the simple model, the linear regression was almost as good, we do have a lot of tools to work with linear models, like variation analysis, instrumental variables, matching, and all these kind of things. Things we can do that that are very easy to do, and we actually are working on that. But the distance to school, yes, I think that could also work as like some type of like instrumental variable of like. It's tricky, but
Maybe as interaction or something like that.
yeah, like how incentivized your parents are to like bring you to school. That yes, something that is easily that we can easily add to the data.
Okay, then. Thanks again.